So this is question 2 from the 2023 Matt. For n a positive whole number and for x not equal to 0, let p subscript n of x be that. So x to the n plus x to the minus n. Sketch the graph of y equals p1. Right, label any turning points on your sketch. So p1 of x is x plus 1 over x. Oh, that's quite an easy one to sketch out. So let's get all 4 quadrants up because we're going to need those. So yeah, we know we got this asymptote x is 0. That's why they put x is not equal to 0. If x is a little bit positive, then we're going to get something very large and positive. So we're up there. If x is a little bit negative, we get something very large and negative. So we're down there. And then the other thing, I suppose, with this is seeing what happens when x is huge and positive. Because this, as x gets bigger and bigger, whether positive or negative, the second term here, the 1 over x, is just going to disappear. So eventually, we're going to end up with a y equals x. So we're going to have a tendency to go off to y equals x. So we're going to have something that looks like this as our graph, because that's our diagonal asymptote. So we want our 2 turning points then. We want a turning point there and a turning point there. So p dash, well actually let's just call it y dash as we're drawing y equals p of x. So y dash is 1 minus 1 over x squared. So we're going to get turning points at x is plus or minus 1, which is going to give that y is plus or minus 2. So that is going to be at 1, 2, and that is going to be at minus 1, minus 2. So fairly straightforward sketch as sketches go. Part 2, show that p2 of x is p1 squared minus 2. Okie dokie. So p2 of x is x squared plus 1 over x squared. Then we got p1 of x squared is going to be x squared plus 1 over x squared plus 2 lots of x over x. So that is x squared plus 1 over x squared plus 2. So there we go. We've got therefore p1 of x squared minus 2 equals p2 of x. Right, so that was quick. Part 3, find an expression for p3 of x in terms of p1 of x. Okay, so p3 of x is x cubed plus 1 over x cubed. So I'm assuming we're going to be following a similar pattern to the last one then. So let's do p1 cubed. p1 of x cubed is then going to be x cubed plus 3x squared over x plus 3x over x squared plus 1 over x cubed. So that is p3 of x plus, what have we got? Get rid of that and that and that and that. That's 3 p1s, isn't it? 3p1 of x. So we've got p3 of x is p1 of x cubed minus 3p1 of x. Right, flying along. So need a new sheet though for the last 2 parts, and these are the big parts. They've actually started giving mark allocations on this paper, which we didn't have before. So part 4, find all real solutions x to this equation. Right, so I've chucked in a quartic equation here. Must be following on from these previous parts. So let's get, well, we could get things in terms of p2s, I suppose, if we divide everything by x squared. So let's divide everything by x squared. So we'd have x squared plus x minus 10 plus 1 over x plus 1 over x squared equals 0. So we've got a p1 and a p2 and then a minus 10. So we've got p1 plus P2 minus 10 is 0. And we got that P2 is P1 squared minus 2. So we've got P1 plus P1 squared minus 12 is equal to 0. So P1 minus 3 and P1 plus 4 is equal to 0. So that gives us that our, well, P1 was so we've got x plus 1 over x equals 3, or we've got x plus 1 over x equals minus 4. So multiply everything by x squared, so we get x squared minus 3x plus 1 is 0. So x is, that's not going to factorize, so we go for 3 plus or minus root of 9 minus 4, so 5 divided by 2. So that's a couple of solutions there. And then we've got x squared plus 4x plus 1 is equal to 0. So x is equal to minus 4 plus or minus the square root of 12 over 2. So we've got a lot of 2's that cancel then. So we'd have minus 2 plus or minus root 3. Okay, so that was not so bad. Let's see what they do with the second one of these. And now we've got, it's power 7 we've got on this one. Okay, so power 7, what I was hoping it was going to be power 6, and then I could just divide through by x cubed, which we got from here, because we've got, let's just write that down again. So P3 of x, that was P1 cubed, wouldn't it? P1 of x cubed minus 3P1 of x. So I've got that bit, just separate that off. But we can't just divide by x cubed because we still have an x to the 4. Maybe we can pull a factor out of this easily. What have we got for our pluses and minuses here? So we've got 1 plus 2 plus 7 makes 10 plus 5 makes 15. And for minuses, we've got 5, 12, 15. Oh, excellent. Right, okay. So x minus 1 is going to be a factor on this. So we've got x is equal to 1 is one solution. So that's one solution. Right, so I'll factorize this thing then. So we got x minus 1 times what? So we'd have to have an x to the 6 there, and at the other end we'd have to have a 1, a plus 1. So to get our x to the 5s, we've got, our x to the 6s, we've got a minus x to the 6 there, so we need plus 3 x to the 5s, which gives us a minus 3, and we want to get minus 5, so we need a minus 2 x to the 4. I've not made this bracket long enough, which gives us a 2 x to the 4, so we need to do a minus 9x cubed, which gives us a 9x cubed, so we need to do a minus 2x squared, and I haven't quite got enough space, so that gives us a 2x squared, so we need to have a plus 3x. So I'll just stick that below. Right, so now we've got something which is in x to the 6, so divide by x cubed plus 3x squared minus 2x minus 9 minus 2 over x plus 3 over x squared plus 1 over x cubed equals 0. So that is P3 gives us that one and that one. We've got 3 P2s giving that one, and we've got minus 2 P1s giving us that one, and then we've got minus 9 is equal to 0. P3, so that is P1 cubed minus 3P1 plus 3P2, so 3P1 squared minus 6. Then we've got minus 2P1 minus 9 equals 0. So P1 cubed plus 3P1 squared minus 5P1 minus 15 equals 0. So that looks like it's going to be, well, we've got all 5s and 3s kicking around here if we're going to try and factorize this. So we want a p and a p squared. And there's going to be a 3 and a 5. The 3 is going to have to go there, and it's going to have to be a plus to give us 3p squared. Put a minus 5 there. Does that work? 3p squared minus 5p plus p squared, p cubed, and a minus 15. These should all be p1s, of course. So we've got that p1 is minus 3. So that would, as we've done over here, well, it's a variant on this one, isn't it? So we'd have x squared plus 3x plus 1 is 0. So that's 1. And then we've got that p squared is 5. So p1 is plus or minus root 5. So we'd have x squared, well, plus or minus root 5x plus 1 is 0. So we've got various quadratics to solve. X equals minus 3 plus or minus the square root of, well, we've got 5 again, over 2. So that's one pair of solutions. And then here we're going to have x is equal to, so plus or minus root 5, plus or minus, we're going to have 4 solutions to this one. This is all over 2. So that will be 5 minus 4. Oh, right, so just 1. So we've got plus or minus root 5 plus or minus 1 over 2. So 1, 2, 3, 4, 5. Oh, plus the x equals 1 solution. So 6 solutions to that one, I think, all in all. Yeah. Right, that was a fairly unimaginative question, really. It was just sort of plugging away through. I suppose the only step was getting that one down to a x to the 6 rather than an x to a 7. But not the most exciting of questions, but at least it was manageable, I suppose, but not much insight.